drag on forever and ever. Once you're healthy.
Wow.
Oh, taking that. All right, here we go. Now, I know if I were you, I know what would be going through my mind right now. What is going through your mind?
Crazy is like that.
Bam. No.
Yeah, I just get
What
it.
does
I only
this say?
What's going through your mind?
2 sine cosine.
Yes, that's what's going through my mind too.
Oh yeah, I think I did this.
However,
No way.
this is going to be problematic. Because why? So we could subtract the 1. I mean, I don't know what you want me to do. We could subtract the 1. We could divide by 2. Those things are perfectly legit. But you see what the problem is? There's like 2 variables, and it's not equal to 0. If it's equal to 0, then you can split them and say this one equals 0 or this one equals 0. But you can't split them if they're equal to negative 1/2. And if you say, well, just move the 1/2 over, then you've got that to deal with. You see, that isn't going to work either. I've got my 0, but I can't split it apart. Would you agree with me? Okay, so we're going to talk about this in a second. I need everybody to understand why this isn't going anywhere. Okay? So here's what I want to challenge you with. What if we went back to the very beginning and said sine 2x equals negative 1? Now, can the sine equal negative 1?
Yeah.
Where does that happen?
3 pi over 2.
3 pi over 2. So the only place that the sine can equal negative 1 is at 3 pi over 2. Would you agree with that? So whatever this angle is, it has to be 3 pi over 2. In other words, 2x must equal 3 pi over 2. So think about it like this. Don't let the fact that's a 2x bother you. What if it said sine u equals negative 1? Wouldn't you tell me u had to be 3 pi over 2? Doesn't really matter what we call this. If its sine is negative 1, it has to be 3 pi over 2. And if 2x is 3 pi over 2, then x is 3 pi over 4. Right? Now, that's pretty easy. There's one more complication to it. Remember, these directions mean that x is between 0 and 2 pi. That's what this means. But when I did the problem, I did it not in terms of x, but in terms of 2x. When I solved this equation, I solved for 2x. So if x is between 0 and 2 pi, where is 2x?
0 and 4 pi.
Between 0 and 4 pi, which means if I'm going to solve the problem from this standpoint, which is 1000% the easiest way to do it, then I gotta go around my circle not once, but twice. So in other words, the first time around my circle, the answer is 3 pi over 2. What if I go around again? What would that angle be if I went around again? 7 pi over 2? What do we call that? What am I doing here? Finding a coterminal angle? And how do I find coterminal angles?
Add 2 pi.
Add 2 pi, in this case add 2 pi. So my answers, 2x, this angle right here, has to be either 3 pi over 2 or 7 pi over 2. Which means the answers to the question are either divided by 2, so 3 pi over 4, or 7 pi over 4. And that's it.
So those are the 4 different answers.
2 different answers. Right here.
And those are the final.
I'm solving for x, but I did my problem in terms of 3x. Now, I know it's not on here, but let me do another one, because we've never done something like that before. Let's try this. Suppose it said, cosine 3x minus 1 equals 0. Oh, that could be better. Let's say plus 1 equals 0. Okay? Now, yesterday we talked about, can we deal with a 3x? If we run into a cosine 3x, can we deal with that? Yes, but it is not fun because you have to split it up into 2x plus x, then you gotta deal with all the 2x's, right? So what if we just said, forget it, I'm gonna do 3x. I'm just gonna say the cosine of 3x is negative 1. And then I'm gonna look at the big picture. I'm not gonna be all hung up about that 3x. I'm gonna say, okay, what angle is it that when I take its cosine, I get negative 1? What has to be in that box, in other words? Pi. So whatever's in that box has to be pi. So 3x is pi. Now, if I do that, and it's easy to do that, I have to remember, though, that I gotta get answers 3 times around. So pi is the first go around. What if I go around again? What's another possible answer if I go all the way around again? 3 pi. Kids, how do you find coterminal angles? That's all we're doing.
Add 2 pi.
Add 2 pi. So 3x can either equal pi, 3x can equal 3 pi, or 3x can equal 5 pi. Now, before you start freaking out, stop a minute. If I took this out and put 5 pi in there, is the cosine of 5 pi negative 1? Yep. It's over here on this side of the circle. Right? Okay. Now, those are all 3x values. My job is to solve for x. So what are the actual answers to the question? X is pi over 3, or pi, or 5 pi over 3. I want you to notice something. Do all of those fit in the interval that we're supposed to be solving in? Yeah, yeah. These are all the possible x values that would make our equation true.
Could we have just originally divided the 3 and then went around and added?
Well, but then what you would be adding is 2 pi over 3.
Okay, because
Because
then you
it's 2 pi
divide
divided by
that.
3, yeah. Yeah, you can do that.
So is the same amount of answers for what that coefficient little thing is?
I don't wanna say that. These angles that I've done have been quadrantal, so I know there's no rules about that, so
It's just played out
Yeah.
that way?
let's say, I can't make one off the top of my head that would make this happen, but let's say, sine, would be sine 4x equals, root 3 over 2. So let's say we had an equation, we solved it and got this, okay? Now, what's the first thing we have to think about? Where is it that the sine, whatever you call it, where is it that it'll be root 3 over 2? Well, it would be quadrant one. Did you say 60 or pi over 3? But it could also be quadrant 2, sine is positive, and that angle would be, okay, so our first answers are either pi over 3 or 2 pi over 3. Does everybody agree with that? In other words, if this said sine x equals root 3 over 2, wouldn't you say your answers are these two? Okay, the difference is, because that's a 4x, I gotta go around 4 times. So I've been around once, this is my first set of answers. What do I get if I go around again? Well, I'm just gonna add 2 pi. So that'll be 7/3. And another 2 pi would be 13/3. And one more would be what, 19/3? Are you following what I'm doing here, guys? Now, another first answer was 2/3. So I'll get 8/3 and 14/3 and 20/3. So these are all the possible numbers that could go in here and make that a true statement. And keep x between 0 and 2 pi. Because look what happens. If I divide all these by 4, or multiply them by a 4th, the littlest one is going to be pi over 12. I'm not going to write them all down. This would be 7/12 and so on. The biggest one would be 20/12. So there's going to be 8 of them now, 8 answers. The smallest one is here and the biggest one is here. But are those between 0 and 2 pi? Yeah. So ultimately your answers are always going to be between 0 and 2 pi. Your x, and these are x's, your x answers are going to be between 0 and 2 pi. But you solved the problem as a 4. You didn't rewrite that. You left it 4x and just went around your circle 4 times. And then went back and divided
So I have
everything
to
by
divide
4.
all those by 4?
Yes. So it would be pi over 12, 7 pi over 12, 13 pi over 12, and so on. Okay, so that one has 8 answers. Okay, got it? So, I'm not telling you to never change these guys, but always kind of take a close look at your problem, because you can deal with it as long as it's the only thing in the problem. If there's a regular cosine in there too, then you're gonna have to. All right, last one. If tangent B is 1/6, find tangent to B. Well, that seems pretty easy after what we just did. What's our formula for tan 2B? 2 tan B
1 minus 2.
over 1 minus tan squared. All right, so 2 times a 6th over 1 minus a 6th squared. Everybody okay with that? Just plugging and chugging? Two 6ths over 1 minus 1/36.
Will we get our little sheet tomorrow?
Yes,
Or Monday?
yes. Now, you simplify that however you want. You know, I'm gonna multiply everything by 36 because that's what I do, but you don't have to do it that way. I just wanna make sure you end up with 12/35 as your answer. I need you to end up with 12/35, whatever it is you're doing, to get it. Okay? All right, I handed back a bunch of stuff. Anybody have a question about something I handed back and you weren't sure what it was I was talking about when I wrote on your paper? Sydney?
Homework 5.2, excuse me, 3B.
All right, so this is a little verified. And a couple people cross multiplied. Look at me, no, no, no. Because when you cross multiply, you change both sides and that's not legal. So, in the interest of saving time, we did one of these in class one day, and we said, look, nothing's gonna cancel, nothing's gonna factor. If this is where I'm starting and that's where I'm ending, I'm just gonna put a sign on the top of my problem because that's what I need to have. That's the only reason I'm doing it, is because that's what I wanna end up with. So then I have on top, sine, 1 minus cosine, over sine squared. Now, again, Sydney, keeping an eye on where I'm going, I would like to have cosines at the bottom. Is that a possibility now? Yes, because sine squared is 1 minus cosine squared. And 1 minus cosine squared is going to factor as the difference of squares. And as soon as I do that, I can cancel, and I'll be left with what I wanted. So that was a matter of just not knowing what else to do, so just sticking in a sign, so I would have a sign, and then things worked out. Maren?
5.21A.
Some of these I think I already did. Okay, remember that a secant in the numerator is a cosine in the denominator, so this is 1 over cosine squared, because secant's 1 over cosine. And likewise, a cosecant in the bottom is a sine in the numerator. So I have a common denominator. And 1 minus sine squared is cosine squared, so it's just 1. It's just 1.
Did you get this sign square? So,
This is 1 over sine. A cosecant in the denominator is a sine in the numerator because they're reciprocals of each other. Okay, who else has one? This could be over the 5-4 homework too. I don't think most of you have turned that in. Yep.
543A.
Okay, here we go. This one says, I know a bunch of things. I always find it helpful to draw pictures. So angle P, this is 5-4 homework number 3A, and finding the tangent of 2Q, which, by the way, what is the tangent of 2Q? 2 tan over 1 minus tan squared. So in order to do this particular problem, part A, I need to know what the tangent of Q is. So what do I know about Q? I know it's in quadrant 3. Oh wait, no, it's in quadrant 2, sorry about that. It's in quadrant 2, between pi over 2 and pi. And the secant, which is the reciprocal of the cosine, is 13 over 12. Now, be careful, the 13 is never negative, so that negative's gotta go on that 12 there. So now I'll do my Pythagorean theorem. I know that one's 5, it's one of my triples, so I know that's 5. A squared plus b squared is c squared. If you have to figure that out, fine, go ahead and figure it out. It's 5. And now, this is a picture of Q. Now I know the tangent is negative 5/12. So I'm just gonna stick it in there. I'm just gonna plug it in, negative 5/12. And just did something like this, negative 10/12 on top, and 1 minus, be careful, these don't cancel. That one gets squared out, 25 1/44. Whatever you want to, I'm gonna times by 144. So I get negative 120 over 144 minus 25. I got negative 120 over 119. Let's see if that's what I got when I did it. Yep. Now, they also gave me information about angle P in this problem, but I didn't need it for this part. I need the angle P stuff for part B. Okay, Ms. McCullough, you got it?
Yeah.
All right, good. Anybody else? We have time for one more. Aaron?
5.2, number 2.
Okay, so the square root of x squared equals x. The question is that an identity? What does it mean to be an identity? It means whatever you put in, it's going to be true. Now, we're talking about real numbers. Some of you are using i's, okay. We're gonna keep things real. We're talking about real numbers. Find a value of x that shows this isn't an identity. Because if I let x be 2, is that a true statement? That is definitely true. But what if I let x be negative 2? What's negative 2 squared? 4. What's the square root of 4? 2. That is not true. Well, I mean, that's true, but negative 2 is not the same as 2. So any negative number will prove or will disprove that. We'll say that's not true. Remember, guys, when you're walking down the hallway and you find that, the answer's 3. It's called the principal root, square root of 9, type it in on your calculator, it says 3. If you're solving this equation though, and you put in the radical, then you have to do plus or minus. If the radical's already there, it's positive, unless it was a negative number. It's called the principal root. So any negative number will disprove that. Okay? All right, you got some work to do. On Monday, we are starting